So today we will start elasticity, plasticity, and viscosity. These three terms looks confusing, but not so confusing. Uh, I will explain one by one. So elasticity, you saw it in your last 2 weeks. What is elasticity? The main, like the in plain language, I can explain that elasticity means coming back to its original position after removing load. That property is called elasticity. That is a very plain language. I do not know anything big in this language. So if I so for a say tension test, it can be tension test, it can be comprehension test. So it is not only tension, maybe comprehension. Even it can be also for bending. So if we apply bending, that is also true. Elasticity, the loading mode. Okay, if I say loading mode or loading rate, it doesn't matter. It so it does not affect the elasticity. What is this? So if I draw the stress versus strain, so that curve will go straight to some portion, then maybe there is some non-linear, but after this, so in this segment, so if my strain goes up, sorry, stress goes up with strain, and if I remove my load, if it comes back to original position, then it is called elastic. Sometimes we call resilient. I believe that you know the meaning of these two words. Same meaning. Resilient means uh, that means after something happens, if we can come back to our original position, that is called resilience. Say there is a flood. Say in this area there is a flood, but after flood, if say everything got like flood means flood is lot water all around your house, your car got sink, everything. So after the flood, within 5 days, you came back to your original normal life. If you can do it, then the city will announce the people in the city all are very resilient. So the in newspaper they will put this word resilient. Our citizens are all resilient. It means what? It means after something happens to us, we can come back to our original normal life, original position. If we can come back, then we are resilient. Same thing here, but technical term for material we call elastic. We call elastic. Resilient is a normal term. Anybody can use, like sociology people, business people, anybody can use resilient. So what is that? If I apply some force, it will come back to original position. Now it can be linear, can be non-linear. Now what does it mean? Say when there was flood, flood occurred in 2 days. Flood occurs in 2 days, and it was linear. The flood was happening linearly. But when after 2 days there might be some non-linear. Third day may be very small flood. Third day may be small flood. So that means the non-linear portion. So when we'll come back, yes, to be resilient or elastic, we should come back to same path. That means third day we will recover small, and in this 2 day we will recover proportional to the flood. So the rate should be um, the flood rate and recovery rate should be equal. So that is the that is the same property for the elastic material. So there will be stress strain. After I remove it, it will come back to original position. That is elastic. And I know that you understood this, and you are hearing this for last uh, 2 to 3 classes. Now I will go to plastic. Okay, hopefully you wrote it down. Yeah, you do not need to write like exactly what I did, the main part at least. Okay, so if I go to next one, now I will do plastic. So what is plastic? So if I apply tension force or compression, whatever it is, if I draw the curve, okay, so two curve here, one is here, one is there. So no, one should be good enough actually. I do not need to. So at the beginning, my stress strain should be linear or non-linear. This is the yield limit. How do we know yield limit? We do not know it actually. After applying load, we have to remove the load and see at which position my stress is coming to back. Okay, then after sometimes it is become horizontal, and if I remove my load, it is coming back this way. Original slope, you can see only this portion is elastic. This portion is elastic, and that portion is equal to this portion. These two both are equal. So, and what is plastic? Plastic portion is here to here. This portion is plastic. Plastic means that this portion will not come back at all. So now plastic may be uh, pure plastic or maybe semi-plastic. Pure, so this is a pure plastic. That means inside this everything is plastic. So it will not come back to original position. If you make some deformation and remove the load, that deformation will not come back. That is called plastic. Okay, now other term is viscous. Viscous or viscosity. Maybe in your handout it is called viscosity. Yes, viscous is the adjective, viscosity is noun, same thing. What is viscous? Viscous means time dependent. I should write this term, time dependent. That will give you full meaning. Time dependent uh, deformation. Time dependent deformation. What is this? Say, okay, so if I apply load with time, now we need to consider about time. For for elasticity or plasticity, time has nothing to do. If we apply load slowly or rapidly, it doesn't matter. But for viscosity, time matters. This is why this time we need to deal about time. Last time we were deal about only stress and strain. That stress strain rate doesn't matter. But for viscous material, okay, and before starting, let me give you some example of viscous material. Asphalt, yes, in civil engineering, asphalt is a viscous material. Or in a normal life, mud is also a viscous material. I know what you know what is mud. If you go to not sea beach has a lot of sand. Go to a lake where there are a lot of like clay particle, muddy. Yes, if you go there, you will see mud. And these two are viscous material. What is this? Say I am applying some load. I am applying some load. Say this is my stress. I am applying some stress force over area. Then how my strain will occur? This is time. If I apply some load at the beginning, my stress will not act. Or maybe okay. Before starting this, let me start with revise that elastic again. Then you will understand better. Let me take a new color. So what I am doing here, I am doing elastic. Yeah, I already told it, but better to show it by sketch. I already told that for elastic plastic, time has nothing to do. And I am drawing I am not telling it in drawing. So elastic, say I am applying some stress with time. If I draw the strain curve with time, what will happen? That whatever my stress, my strain will be proportional. That means whenever I am applying the load, instantly my strain will occur. That is called stress, and that will not change. Yes, and then if I change my go. So if I change my stress value, yes, my strain will also change. It is like similar with the force. That means whenever I am applying force, the deformation will be instant. instantaneous, or the deformation will occur instantly, this right same time. If I remove it, it will come back to original position at the same time. It will not take any time. It will not take any time. Now, for viscous material, it takes time. So if I apply some load, how my deformation will occur? At the beginning, it will be zero because it takes time. Then it will occur like this. It takes some time. So it takes some time at the beginning. Now, this rate may change depending on the material. Some may go this way. Yeah, this will not go this way. That is like a more accurate. So depending on material, say mud, asphalt. This asphalt is the most common material we use in civil engineering, so we should know it. Now, depending on material, the nature of this curve will change. But again, like nature means like the severity, the slope might change, but the nature will be same. That means at the beginning zero, it go with time. Now, to give an example, if you go to lake and jump on a mud and stand there, then you will see that you are sinking with time. I think that you saw it. That say you went to water, and then you keep on sinking slowly. So why? Because it is a viscoelastic material. The deformation occurs with time. Okay, so this property is called creep. Now, what is creep? Creep means it is a relationship between, if your stress is okay. I should take a new page for this. Okay, I'll go to new page, but very quickly here. If I keep my stress constant, my strain will increase with time. I wrote here in a symbol. I don't know whether you understood or not. Okay, I will draw it again. I will go to a new page, but again before that, uh, just I am revising whatever I did. If I apply a constant stress, constant, it is not changing. It is not changing with time. My strain will increase with time. That increase in strain with constant stress is called creep. Creep property of viscous material. Viscous materials have two property. One is creep, other one is relaxation. Okay, so in next slide I will talk about that. So what we are doing here again, viscous, and it has two property. One is creep, one is relaxation. Relaxation, and I know that you know what is relaxation. Relaxing. Yes, we like to relax sometimes when you go to sea beach. We like to relax. Same thing, same thing. So what is that? So first we will do creep. Creep. What is creep? If I apply a constant stress, my strain will increase with time. That is called creep. So this figure will tell you everything. Now this question is in your MCQ test, and also there's a good chance you can get it in your AP exam also. Then we will do relaxation. What is relaxation? Opposite case. If I apply some constant strain with time, my strain is constant. Okay, right here constant, right here constant, right here increase with time. Now, so if I am doing not constant stress, constant strain, now what will happen? If you can guess something, try to guess something. That means, say a rubber band, if you pull it and hold it, what will happen to your force or stress? Try to think. If you cannot find it, I am telling you the answer. Yes, when you pull something, there is a stress. But if you pull the rubber band and hold it like this, with time you will see that you do not need the force that you were applying at the beginning. That means your stress will decrease. That is called stress relaxation. So we call stress relaxation or simply relaxation. So it is stress relaxation. That means if we apply constant stress, constant strain, my stress decreases or relaxes. That is called relaxation property of viscous material. So viscous material has two property. One is creep, one is relaxation. So hopefully you understood that one is for constant stress to strain, one is constant strain to stress. Okay, so hopefully you understood creep and relaxation of viscous material. Then we'll go to a new, okay, maybe extend little bit. Do not stop here, extend a little bit. I'll go to my next slide. Okay, again, this question is in your MCQ test or maybe in your FE exam also. It is just to understanding. Okay, next slide is what about mixer? Mixer means, say we are talking about viscoelastic. What is this? Now, before starting this, just to tell you, in this world, there is no material which is perfectly elastic. No material which is perfectly plastic. No material, oh, I should not say perfectly, only perfectly elastic. No material. There is no material which is only perfectly plastic. There is no material which is perfectly only viscous. So these are the property which exist like combinedly. So I can give you an example. There is no man in this world who is full honest, never lied. In this current world, if you argue like our prophet, religious leader, they are full honest. Yeah, I'm not going there currently. So now it is 2021. So in 2021, there is, no, I believe, maybe my statement is wrong, but I believe there is no man, no woman in this world who is perfectly a full 100% honest. Even same thing to me. I lie sometimes to my kids, to my wife. Yeah, in fact, we sometimes we need to, but we should not. Okay, so yes, at the same time, not everyone, not all of the person are not 100% dishonest. No. So at the same time, not 100% people are dishonest. So there's a mixture. Even I can mix something more inside: honesty, dishonesty, short-tempered, cool-tempered. So this way, so there is nothing pure or only one thing in a life. So in one person. Same thing for material. It is not perfectly elastic only, not perfectly plastic only, not perfectly viscous only. There is mixture. No, so now we are talking about viscoelastic. Now, why viscoelastic? Because as per I told that it is a viscous material, but it is not fully viscous. It is some part viscous, some part elastic. So in that case, what will happen? So if I apply some stress with time, stress with time, what will happen to my strain with time? Excuse me. Now, is it difficult? No, I already discussed it. What is that? Elastic portion. If I take a new color, elastic portion is instantaneous. Instantaneous. Viscous portion takes time. Say it takes time. So one is instantaneous, one takes time. So I am applying a constant stress. What will happen to my strain? That is the question. Is it difficult? No. Elastic is instantaneous. Whenever you will apply your load, deformation will occur at the same time. There is no lagging. If you apply your load 121 23 second, at this time your deformation will occur at the same time without any delay. So I applied some stress, I will get some strain instantly. So this is my strain. So ideally, if it is elastic, it will be like this. If it is elastic, it will be like a linear line. But it is not elastic. There is some part which is viscous. What to do then? So this portion is done. Then viscous. This portion is viscous. So this portion is elastic and this portion is viscous. Done. This portion is viscous. If I draw, okay, make sure that you understood. If I go slow, stop me, because to me it is very interesting, so I go very fast and I get excited. But for you, maybe it is the first time you are hearing this. In your 207 class, you were supposed to learn little bit, not so much. So if you did not, I'm doing it here. So now what I will do, opposite case, the strain. Say I am applying a constant, okay, right here, constant, 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 constant strain. Now what will happen to the stress? Is it difficult? No. Just remember, elastic portion is instantaneous. Viscous portion takes time. So whenever there is some stress, there will be some, when there is some strain, there will be some stress instantly. So this is for elastic case. This is for elastic case. But my material is not elastic. It has some viscous component. So what will be? Then my stress will decrease. So okay, this will be the viscous. That means now this shape may change. Like this shape, it may be very slow, very fast. We cannot tell exactly. It depends on the uh, material. So what I was telling. Oh, viscous, visco, elastic, and material. Some part is elastic, and some part is viscous. Now, in your book or in your handout, there is a very big figure, and it shows different. Maybe I did not discuss plastic. That is just I'm missing something. Yeah, plastic will go. Plastic actually, the strain does not come back. Okay, so better to take the figure from the handout. A big figure, it has everything. But at least you understood that what is elastic, what is plastic, what is viscous. Yes, this figure. One figures will tell everything, compare everything. Now, in this case, what I am doing? I am doing both. That means not only constant stress or constant strain. I will apply load and I will remove load to see better. See, at the beginning there was no load. After sometimes I applied some load and kept it for some times and then remove my load. Now why I did it? Just to show different scenario. Because last time here when I showed it, I did not. I show only constant stress, constant strain. But here I can show you many things at a time. Okay, so whenever I am applying load, if the material is elastic, if the material is elastic, the deformation. See, there is no load, no deformation. Whenever there is load, the deformation is sudden, and my load is constant, deformation is constant. Load is removed, deformation is removed perfectly. That is elastic. I think this portion is very clear to you. There is load, there is deformation. There is no load, no deformation. As long as there is load, the deformation will continue. Plastic. Plastic is, it doesn't come back. Once we apply load, it deforms, it never come back. Okay. So next one is plastic. At the beginning, no load, no deformation. Okay. Now, whenever I apply load, you can see whenever I apply load, deformation jumps. And there's load, there's deformation. But after coming here, I remove my load. See, deformation did not come back. It is as it is. So that is plastic. Once deformation occurs, it will not come back. Now this plastic means is fully plastic. It has no other component like elastic or something else. Now we will combine elastoplastic. So elastoplastic. Okay. So we are doing here. At the beginning, no load, good. There is load, it jumps. There is deformation. After coming here, we are removing the load. If you remove the load, elastic portion will come back, but the plastic portion will remain. See, it makes sense. And that this coming back is sharp. Why sharp? Because elastic deformation and elastic recovery, both, they are instantaneous. They do not take time. So suddenly jump. Hopefully understood. Second case, viscous, pure viscous. Okay, so what is here? So we, here there is no load. So when there is no load, there is no deformation. True. When there is load, deformation starts increasing, increasing, increasing. See, it takes time. It is not constant. It increases and then recesses there. Once it recesses there, if I remove my load, then it is coming back. Now, if it is only for viscous, if it has somewhat some elastic or plastic component, that will be different case. It is pure viscous, so it will take time and come back to original position. Again, it will come back to original position, yes, but with time. How much time? Depends on the material. We cannot tell it now. In fact, that is a big research topic for different materials. Say for asphalt, how much time it takes to come back? It depends on the load, depends on the loading rate, depends on the temperature, depends on the asphalt type. Now, what is asphalt type? There are thousands type of asphalt. Simple answer is thousands type of asphalt. Okay, so deformation for viscoelastic, very common material for asphalt. Viscoelastic, some part elastic. So whenever I apply load, elastic part jumps instantly. Viscous part takes time, takes time, takes time. Over there. When I remove load, elastic part come sharply, instantly. Viscous part will take time. Viscous part will take time. Now, hopefully you understood this. Mm, no, so this figure, it is a very, I don't know. When I drew this figure, I took about whole 1 day to draw this figure because this figure is not commonly available in books. They put something one or this not in the same time every material every. Now there are more combination. This is not all the combination. It can be viscoelastoplastic. It is possible. It is possible viscoplastic. It is possible. But in civil engineering, these are the some basic, and we are like we are like covered by this property. There are many other property we do not need to deal about this. We need to deal about mainly viscoelastic, mainly viscoplastic, and pure elastic. These are the three property we need a lot. Oh, I'm talking a lot maybe. Let me stop my video to make